variance value of a set of data is a measure of how spread out that set of data is from its mean value. And here we can look at two different examples of a set of 6 numbers where we work out the variance. And example 1 has 6 numbers that are quite close together, whereas example 2 has 6 numbers that are quite a lot more spread out. The first thing to do is to work out the mean values. In example 1 we have a mean value of 19, as you can see here on the number line, and example 2 has a mean value of 42, as you can again see illustrated on a number line. So now that we know the mean values, we can look to work out the variance. And there's a standard variance formula that can help us to do just that. This is the formula for the variance that we can use, and this is the commonly used symbol for the variance. So if we put our respective values for example 1 and example 2 into the variance formula, we get the following, where we have our first value in our list of data minus the mean squared, the second value minus the mean squared, all the way up to our n, which is our 6th value, 24 minus the mean squared. And this is all over the number of values there are, which is 6. And when we carry the calculations out, for example 1, we get 84 over 6, which gives us a variance of 14. And for example 2, where the numbers are quite a bit more spread out, when we work this sum out, we get 1520 over 6. And to do decimal places, this gives us a variance value 253.34. So, as we could see from the number lines, the set of numbers in example 2 are quite a lot more spread out from their mean value than the numbers in example 1. Hence, with a lower value of the variance for example 1's numbers, whereas example 2's is quite a lot higher at 253.34. There is also an alternative formula for the variance, which some can find easier and prefer to use, and which will also give exactly the same result. And this is where we sum up the square of each value in our set of numbers all over the total amount of numbers there are minus the mean squared. So we can show how this would look with the numbers from example 1. This is how things would look using this approach, and as stated, the final sum will give us exactly the same numerical value for the variance.